This problem is a pretty straightforward problem. This is called delete operation of two strings. Let us read the problem statement. Given two strings word1 and word2, return the minimum number of steps required to make word1 and word2 the same. In one step, you can delete exactly one character from either string. So basically, what we have to do is we have to delete some characters from word1 and word2 and try to make word1 equal to word2 in the process. And we obviously need to do the minimum number of deletions, try to optimize our deletions. So I'll just get to the main idea of this problem. This is a pretty simple problem, very standard problem, DP problem, right? So basically, let us take one of the examples that is given here. So SEA and EAT. So one is SEA and EAT. So how are we going to do it? We'll start with the last character. We'll start with two pointers. One pointer pointing to the words one last character, another pointer pointing to the words two last character. And suppose what we do is we delete this, right? We decide to delete this, so we have one operation, and then these points here, right? And then we find a match, right? This is a match, so we don't do any deletions. We move this pointer forward. We move this. Sorry, let me delete this. I need to select basically. So we move this pointer forward and move this pointer forward too. To better select. Yeah, moving this pointer here on on here, right? Let me delete this. Yeah, so this is it, right? And then again these two are same, so this will be moved here and this pointer will be moved here. Sorry, this pointer moved to here, right? And then obviously now we have to essentially find a match between an empty string, which is this one, and a string which is s, which is this one, right? And that will basically delete all the characters in the non-empty string. There is only one character in the non-empty string, so we have to do one more deletion. So that means in the total we had to do 1 plus 1 equal to 2 deletions. So that's the essence of the problem. Whenever we find a whenever we find a match, we basically shift both the I and j pointers leftward. And then if we don't find a match, then we can do two things. Either we can, so suppose we have like character x and y here, right? And then some characters here, and our I is here, right? And then our j is here. Either we can delete this and check what happens if we take these two characters and try to compare, or we can do the other way around and delete x and check how it works, right? We can also delete x, then we have to check this kind of string and see and try to match them, right? So that's the idea. I think it's pretty simple enough. The base condition is obviously if we try to compare a null string with any string of any length, then so any length, suppose this is a arbitrary length L, and obviously you have to do L deletions to make these two strings equal. That will become our base condition. So now let us look at the problem and see how it is solved. First of all, we basically figure out the length. Pardon me. Let us look at the solution and see step by step of how things are done code wise. So now we basically store the length of the first word and the second word in two different variables called n and m, right? And then define a vector initially. This vector stores. This is a DP array which is able to with which we'll find our answer, right? And I have kept at n plus one. So basically, what it means is uh, the ith character in the string and corresponds to I plus one index in this kind of DP array, 2D array, right? So and then the row wise, if you go row wise, and that basically represents the word one, and then if you go the column wise, that represents word two. That's generally how DP for I mean 2D DP for which takes two words as input works, right? This is I'll explain this in the later steps. So again, this is we are trying to find a match between a string with I included up to the ith character or I minus one character, right? And another string which has no character. So that will obviously be I. That will be I. And then another string, because up to I minus one character the number of characters is I, right? So that's why here is I. And then another string again for the second string we have not taken anything from the first string, and then for the second string we have taken up to j minus 1 character. So 0 to j minus 1 will be j characters, so that's why number of deletions that we have to make is j here, right? And then moving forward is a simple step. If the two if the character uh, at the I minus 1th location, which is whose representative is at ith index in the array, right? They two match, then we obviously we just move the both the I and j leftward as I showed in the diagram. And if they don't match, then we will take the minimum of either deleting the ith I minus 1 character or deleting the j minus 1 character, right? So either we delete the I minus 1 character or we delete the j minus 1 character, and then we see that in which route we are getting the minimum number of deletions to eventually make the two strings equal. And then that becomes, and obviously since we are deleting one element here anyways, either we are deleting the I minus 1 element or the j minus 1 element. So definitely in both the cases we are deleting one element, so we have to add one here, because this dp essentially stores the number of deletions. And then basically this means that what is the number of deletions that we have to do to make uh, the string s so the string word1 ranging from 0 to n minus 1 means the entire characters of the word1, and the string word2 from character starting from 0 index to m minus 1 index, that is all the characters of word2. How to make these two equal? That means basically making word1 equal to word2, and that is stored here, right, eventually, and that we return. So that is basically the code. It's pretty simple, straightforward. The dp equations are like very simple. These are the main dp equations, right? And hopefully you have understood this problem. This was a pretty simple problem for this week. I'll see you in the next video. Thank you. Bye.